You all there? Page 109, number 4 on the practice. Yep, that's the one that we kind of left off on that page. Right? We already did 1, 2, and 3 on that page. So tell me the ABCs of graphing a quadratic function in standard form. What does the a value do? So in this problem, the a value is -1/2. What does that tell me? Concavity. So is this graph going to open up or down? -1/2. So it's going to open down. And is it going to be steeper or less steep than the parent function? Less steep. So I'm just thinking that in my head for now. What's the formula that I use with b to find the vertex? -b over 2a. So -b in this problem. Ladies, I'm going to go. So this is, you want to be focusing when we're doing new notes so that you feel like you're getting it. So if I got -b here, I want to do +2, right? Because negative, it means opposite. So if it already is -2 in the problem, it's going to be 2 when I calculate the vertex. And then 2 times a. A in this problem is -1/2. What's 2 times -1/2? 2 times -1/2. So what's -1/2 plus -1/2? -1. 2 times -1/2 is -1. And what is 2 divided by -1? -2. So the x value of my vertex is -2. How do I find the y value of my vertex? We practiced this last time. Plug the answer into the original function. So let's do this one together because there's that ugly fraction sitting there. So what happens when I square -2? What's -2 times -2 for that x squared? +4. So I'm just going to write it down here. I've got -1/2 times +4. Then I'm subtracting 2 times -2. And then I'm going to add 4. So what do I get as my result? This is -2. This is +4. And this is +4. So what's -2 plus 4 plus 4? -2 plus 4 plus 4 is how much? 6. So my vertex is at -2, 6. So I'm going to plot -2, 1, 2, 3, 4, 5, 6. There it is. We already said it was concave down. Originally, if I go 1, 1, 2, 4, 3, 9, I'm cutting my y values in half. So I only want to go up 1/2, up 2, and up 4.5. Actually, in this case, I'm going down. Down 1/2, down 2, and down 4.5 from the vertex. So over 1, down 1/2. Over 2, down 2 from the vertex. And over 1, 2, 3, down 4.5. 1, 2, 3, 4.5. So it's concave down and it's half as steep as the parent function. So over 1, down 1/2, over 2, down 2, over 3, down 4.5 from my vertex. And my vertex was this point right here, -2, 6. How can I check that I did this right using the C value? What does the C value tell you? The y-intercept should be 4. Is my y-intercept at 4? Yes, it is. I should have hit 4 on the dot. So I always use the y-intercept to kind of check my work at the end. So standard form is on the homework tonight. You need to do the ABCs of standard form. I'm going to flip back a page because we never finished intercept form. And I want to show you intercept form, and then we're going to practice them a little bit. So intercept form, y equals a x minus p x minus q. That's intercept form. And the x-intercepts are at p, 0 and q, 0. Because this is in factor form, remember factor form? If I plug in intercept form, I'm going to say that the vertex, the x value is halfway between the intercepts. So we can find the x value, and then we have to plug that in to find the y value. I like intercept form if it's given in intercept form. We're going to review how to FOIL. Remember how to FOIL? Multiply out either using the box method or distributing binomials. I don't know why you'd want to put this in standard form just to graph it. If it's in intercept form, it should be easy to graph in intercept form. All right, so what are my two x-intercepts? What will make this equal to 0? X plus 2. What will make that equal to 0? What does x have to be? We went back one page to intercept form. What goes in this parenthesis to make it equal 0? -2. Would everyone agree if I plug in -2, I get 0? Okay, so -2 is one of my x-intercepts. What's my other x-intercept from this other factor? What would I plug in to make this factor 0? 4, because 4 minus 4 is also 0, right? Kind of remember factored form? We're going to review that starting kind of tomorrow. If those are my x-intercepts, you plot your x-intercepts on your graph. Can I tell if this is concave up or concave down yet? This is the A value, right? A tells you concave up or concave down. What's my A value? 1/2. So I know that the vertex sits somewhere underneath and it's concave up through these 2 points. The x value is halfway between the intercepts. What's my x value? What's halfway in between? All right, so my vertex is going to be at 1, something. There's an axis of symmetry right here. My vertex is somewhere on this axis of symmetry. Once I know x, how do I find y? Plug in the x value to find y. All right, so let's plug it in. I would have 1/2. What's 1 plus 2? That would be 3. And what's 1 minus 4? That would be -3. So what is half of -9? -4.5 is my vertex. 1, 2, 3, 4.5. That kind of makes sense because if I go over 3, I go up 4.5 to hit that x-intercept. Can I read my y-intercept from this function? No. I would actually have to plug in 0 for the x's and calculate it out. But if I'm here, if I go over 1, I go up 1/2 and I actually hit my y-intercept. And if I go over 2, I go up 2. So I'm kind of like halfway in between right there. That's just the start of the next lunch. So this one is a little bit harder with that stretch of 1/2, but if you just showed me where the vertex was and the 2 x-intercepts and put your parabola, I would have counted it correct. Okay, let's see if we can do one more intercept form together. What are my 2 x-intercepts? So what will make this parenthesis equal 0? When x is -1 and when x is +3. So my x-intercepts are the opposite of the factors, -1 and +3. Now I'm thinking in my head, is this concave up or concave down? It's concave down, so my vertex is going to be somewhere up here above the axis. I need to go halfway in between. What's halfway in between? 1 again. Well, it's a total distance of 4, right? So it'd be exactly at +1. Once you know your x value, plug it back into the equation and tell me what the y value is. So you're going to plug in negative. This would give you a 2, and this would give you a -2. -4 looks like. So +4, right? Whenever you have an x, you plug in to find the y. 1, 4. 1, 2, 3, 4. So it's concave down through those points. I could actually find one more set of points. This is just the parent function flipped upside down, right? My a value is technically 1 right there, over 1, down 1. So this is a concave down parabola that's the same steepness as the parent function. And it's going to take some practice for you to get used to all 3 of these formats graphing a quadratic. So that's your goal for Friday this week. Without a calculator, I'm going to give you like 3 different graphs. So you have to know how to do it in standard form, how to do it in vertex form, how to do it in intercept form. But you'll have a bunch of practice to get there. And I think vertex form you should be really good at from transformation rules, right? Let's do 5 together, and then you can try 6, 7, and 8 in your groups, because that's vertex form practice. Then maybe you guys can try together your intercept form practice. So let's see. Tell me what's going on in question number 5 right here. Do I go right or left? It says x minus 3 in parentheses. So I flipped ahead another page. So am I going right or left in problem number 5? So I'm going right 3 units. And am I going up or down based on this plus 5? So I'm going up 5 units. So my vertex is at right 3, up 5. So I'm going to plot my vertex on my axis. Does anyone know what AOS would stand for? Axis of symmetry. Just practicing, because your book asks you what the axis of symmetry, that's just a vertical line through your vertex. How do you write the equation of a vertical line? Good practice from linear stuff. It's undefined, so it's x equals 3 is that axis of symmetry. You'll see that on the homework. They'll ask you what the axis of symmetry is. All right, what do I do next? I look at my a value, which is 1. So that tells me it's concave up, and it's just the normal parent function 1, 1, 2, 4, 3, 9. Those points should start to stick in your head. So over 1, up 1, and over 2, up 1, 2, 3, 4. That's all that I can fit on there. So I hope that number 5 feels really familiar, like we spent all week last week doing transformation rules. So you can figure out your left or right, your up or down, and you should have memorized that parent function. So we're just going to keep using that same parabola. So it helps you to write that parent function on your paper. 1, 1, 2, 4, and 3, 9. Those are the moves from your vertex. So once you find your vertex, those are the moves to get the rest of the parabola. So I'm going to pause